Welcome back. In the previous video, we learned the advanced properties of inverse trigonometric functions and, more importantly, why those properties actually work. Today, we are going to use those very same properties to solve exam level questions. If you haven't watched the part 1 yet, highly recommend watching it first because in today's video, we will apply those identities directly without proving them again. So our question 1 is evaluate tan inverse of 1/2 plus tan inverse of 1/3 plus tan inverse of 1/5. And to evaluate this, we need to use one formula that we discussed in part 1, which is addition of tan inverse. So first we will combine the first two terms, and that are tan inverse of 1/2 plus tan inverse of 1/3. Now before adding, we need to check the product of x and y here. So here the product of 1/2 and 1/3 is equal to 1/6 and it is less than 1. So we can directly apply the formula. Do you remember what was the formula? So whenever we have to add tan inverse of x and tan inverse of y, what is the formula? We use formula this. This tan inverse of x plus y upon 1 minus x1. Let's apply the same formula here. So we have tan inverse of 1/2 plus 1/3 upon 1 minus the product of 1/2 and 1/3 is 1/6, and further simplifying inside the bracket we get tan inverse of 5/6 upon 5/6. Okay, and then we have that is equal to tan inverse of 1. Okay, now we know that tan inverse of 1/2 plus tan inverse of 1/3 is equal to tan inverse of 1. So let's use that. We have now expression tan inverse of 1 plus tan inverse of 1/5. Now let's apply the same formula again to simplify this. So after applying the formula, we have tan inverse of 1 plus 1/5 upon 1 minus 1/5, right? So our final answer is tan inverse of 3/2. Okay, isn't it simple after using that formula? Let's move to this question number 2. Find the complete set of values of x satisfying sine inverse of x greater than cos inverse of x. So before solving this expression, we should know the formula or identity that we have discussed in part 1, which is sine inverse of x plus cos inverse of x equals to pi/2. So now let's substitute cos inverse of x equals to pi/2 minus sine inverse of x. So we will write here just a second. Sine inverse of x is greater than pi/2 minus sine inverse of x. Now let's take sine inverse of x from this right side to the left side. So we have twice of sine inverse of x greater than pi/2, and then we have to keep only sine inverse of x on this side. So we have sine inverse of x greater than pi/4. Now we need to find the value of x, so take the sign on both the sides. So we have sine of sine inverse of x, which is equal to x, that is greater than sine of pi/4. And you know that what is the value of sine pi/4, which is equal to 1 upon root 2. So our x is greater than 1 upon root 2. So including the domain of sine inverse, the final answer is x is greater than 1 upon root 2 and 1. 1 is included. This is our final answer. We need to put a square bracket here because 1 value is included in the domain of x. Here is a very important question. In this question, we have to find cot inverse of under root 1 minus x square upon x for the given domain of x. Now, let's put x equals to minus sine theta. Because x is minus sine theta and theta lies between 0 and pi by 2. So we have here under root 1 minus x square equals to under root 1 minus sine square theta, which is equal to cos theta. And the term under root 1 minus x square upon x becomes equals to cos of theta upon minus sine theta, and that is equal to minus cot theta. So here what we need to find is now cot inverse of negative cot theta. Now here comes the very important step. So this expression is cot inverse of minus cot theta. Now we know that cot is negative in the second quadrant. So use the identity cot of pi minus theta equals to minus cot theta. Okay? Because we know that cot is negative in the second quadrant and the principal value of cot inverse always lies between 0 and pi. So the required angle is pi minus theta. So we will write here cot inverse of minus cot theta is equal to, we will replace this minus cot theta as cot of pi minus theta. And therefore we have here cot inverse of cot of pi minus theta, which is equal to pi minus theta. Now let's come back to here. What we know that we have substituted x equals to minus sine theta. So that is why we can say that theta is equal to minus of sine inverse of x. That is why here we can write cot inverse of cot pi minus theta equals to pi minus of minus sine inverse of x, that's why it is pi plus sine inverse of x. Okay, so our answer is cot inverse of under root 1 minus x square upon x is equal to pi plus sine inverse of x. Okay, so this is our final answer. Which question challenged you the most? Was it principal value problem, the inequality problem? Let me know in the comments below. If you found this video helpful, don't forget to like and subscribe to Maths with Anu and turn on notifications so you don't miss the next part.